Good morning, everyone. Greetings from Riga. I hope you have all had a nice time during the networking event yesterday. For me, it was a really nice vibe, and I really felt like part of the Baltic MSP family again, so really enjoyed it. And there is still one of the activities from yesterday that is available also today. If you go to the chat, then you can still join the make a selfie, MSP thematic selfie, and join it to the picture gallery or the family picture. But now let's shift back to work, and we still have an exciting day ahead of us. And now I would like you to welcome to the workshop number 8 about the tools for data-driven decisions. And so just a reminder that you are now on the alpha stage. And I think by now you all know that my name is Liene, and I've coordinating the policy area spatial planning, and this task has also allowed me to follow the work of the BSR MSP data expert subgroup and other MSP data related activities in the region. And however, today I'm here just to support you technically, as I am on the spot in Riga. And this workshop has been organized by Capacity for MSP and HELCOM, and it is my great pleasure to assist you here. And in a minute, I'll give the floor to the moderator of today's session, but I have to share some practical details with you. First, we will have short interactions in the middle of the workshop and at the end of the workshop, and you can answer to the polls and contribute to the word cloud. And I think by now you already know how to do it, but it's on the right side. If you click among the different icons, you will find it. Secondly, you can always ask questions to the speakers. You can do that in the chat. Please tick the box, ask your question via moderator, so it's easier for me and Andre to notice those questions. And yeah, you did great interacting yesterday, so I'm confident that you will keep up the good work today. And last but not least, I invite the speakers to stick with your allocated time, so we have time for discussions at the second part of the workshop. And yeah, so that's about the technical stuff. And now I would like to introduce the moderator of today's workshop. And please welcome Mr. Andrej Abramic from the Eco Aqua Institute. If I'm not mistaken, he's joining us from the Canary Islands. A nice destination that the Baltic countries definitely enjoy. And hopefully we can visit you soon again. And but I will let himself to introduce himself a bit more and tell about his tasks that he's been occupied with lately. And Andre, it is my great pleasure to welcome you to the Baltic MSP family, and the virtual floor is yours.
Thank you, Liene, and welcome everyone on the workshop. And of course, you're all welcome to come on the Canaries. You're all going to be informed when we organize some nice event as here. Also, I'm really thankful to the organizer, Deborah Florent, that they invited me, as I'm from Mediterranean, currently working in Atlantic, and being involved actively in this workshop in the Baltic Sea. So my name is, as Lina said, it's Andrej Abramic. I work in the Eco Aqua Institute at University Las Palmas de Gran Canaria, and I'm working mainly on the projects of the Maritime Special Planning. I'm coordinator, principal researcher in projects Plasmar and Plasmar Plus, which we are developing, and there are also other MSP initiative in the region. Today we have a quite interesting topic with the tools for the data-driven decision making in MSP. I believe that we are all agree that MSP is data-driven process, and that we need effects for the decisions, for that we need effects that we can actually introduce within the planning. So when we talk about the facts, we need a special information, special data, not just on the marine environment and marine activities. We also need to introduce the data on the marine conservation, on what is going on within the coastal activities, or what are the actually changes within the oceanographic parameters within the climate change. And also, if we want to support ecosystem approach, ecosystem-based management, we should also include the data on the society, or social needs, or the economical development. So all this we find quite difficult to manage. We see that data, when we are collecting data, we're collecting data from the different data initiatives. We're collecting data from the different projects, and it's very difficult to manage it. But this is actually not the goal. We need to assess all this data to develop the scenarios. And this is why within the last 10 years, not only in the Baltic, there is lots of development of decision-making tools. What is the topic practically of our workshop? So within this context of the workshop, we want to discuss what are the different approaches being used to handle data challenges, and what are we will have an overview of the recent work done by the different international projects, mainly of course in the Baltic, and how they address the challenge of accessing and providing data to support decision-making processes within the MSP. So the workshop objectives will aim to answer the following challenges. And the first one is how to access relevant data to support decision-making in the MSP process. Here we are not talking about the data which are needed for development of the plans, because the most of the European countries has a quite advanced MSP process, but that can be actually included in the next phase in the monitoring of the MSP plans. The second one challenges how to work with decision support system, which we use it to understand where the maritime activities will have a less environmental impact, where we have where the location which will have a less potential for the conflicts. And finally, how to assess cumulative impacts of the human activities in marine environment, which I believe is quite a burning and interesting topic. So I was not invited to speak here. Maybe it is a good time to introduce our first presenter. It's Joni Kaitaranta. I believe most of you know him. He's working in the HELCOM Secretariat more than 10 years, from 2010. He's a data coordinator, and his tasks include coordination of the HELCOM data collection activities, which includes steering of data-related work within the Secretariat, cooperation with expert groups, and coordination with outsourced data hosts. He's very active on the international environment and the European groups, and starting with the HELCOM VASAB MSP data expert group, but also an MSFD working group of data information and knowledge exchange, DIGDIC. And also from the last year, he's acting as a co-chair of EU technical expert group on MSP data. Joni holds master's degree in limnology from University of Helsinki, and he also has a postgraduate study with focus on geoinformatics, computer science, and the fisheries science. So Joni, please unmute yourself, and the floor is yours. You have 15 minutes for the presentation.
Thank you, Andre, and good morning from Helsinki. And it's indeed time to dive into the topic of data, which is not the easiest ones to start the morning with, but let's try to do that. And the title is Data for within the Baltic Sea to support cumulative impact assessments. I hope the slide clicker works. Yes, so the Baltic Sea has several uses and activities, as we all know, and there is a lot of overlapping activities, and it is also a very fragile ecosystem. So there is definitely a need for have this evidence-based decision making, and that requires data and analysis tools, and also it requires these assessment schemes, how the data is collected, how the data is harmonized, and how the data is analyzed to give this cumulative impact assessment. So the main challenges is, first of all, to access the data. First of all, the data might not simply exist, and if it exists, there might be issues in accessing it in the required format and in the required way. And also there is the variety of assessment schemes available and developed, so there is some development needed for that. And one of the main challenges what have been faced is how to access this data that supports not only MSP but also the cumulative impact assessment tool. So something that really feeds into cumulative impact assessment tools so that they can be really used for the purpose that they are aimed for. And what we can offer from within the Baltic side is that within HELCOM and other initiatives, there has been on the national level, of course, making a lot of data available on human activities and MSP plans and environmental data. And that has been collected in HELCOM for base maps concerning the human activities that are relevant for MSP, and also in the HELCOM Map and Data Service, which contains all and everything on Baltic marine environment that is collected under HELCOM. So there is a quite good availability of human activities data that we know rather well. It might not be that well harmonized, but due to the nature of the data that it is humans doing the activity, it's quite easy to know where the pipelines are, where the dredging activities take place, where the certain fisheries gear type fishing activity takes place. So there is quite good data available on that, even on quite detailed spatial scale. However, for the environment, the situation is not that good because, of course, to collect this environmental data, there is a lot of expensive surveys that needs to be done. You have to do this in situ data collection. And for this data to be useful for the cumulative impact assessment tools, it has to be in very high resolution, and it should have a coverage that includes the whole Baltic Sea in very high resolution. So that is quite challenging aspect. And I think the only way to get some sort of data products that are helpful for the cumulative impact assessment tools for this is to combine this with modeling to be able to come up with something like this, which is on the screen, which is from the Pan-Baltic Scope project on potential spawning areas for herring, for example. So this is one of the good example of ecosystem component data product, which is of high resolution and it is harmonized across the Baltic Sea. So this is something that is quite nicely needed and not that much available at the moment, but something to really strive for. And of course, one of the requirements for the data in the international context is that it should be harmonized between the countries so that there is no apples and oranges from different countries stemming from various reasons. Then the other challenge is the assessment schemes and what kind of different approaches there has been to address those challenges and what kind of tools there have been developed in the Baltic for the cumulative impact assessments. In this presentation, I will present very briefly four of the tools that have been developed from projects and from the national side. So I will start with the Baltic Sea Impact Index, which was developed in HELCOM for the State of the Baltic Sea report and published in 2018. And it is used to calculate Baltic Sea pressure index, which is simply a sum of all pressures. So it overlays on a map which areas there is most pressures. Then it also includes this Baltic Sea impact index, which tells where the pressures have a most highest effect to the ecosystem components. And that analysis is based on this sensitivity score table, which is shown in the screen as well, that there is this kind of matrix which tell which ecosystem component is affected by each pressure. So this kind of a Halpern-based method to analyze these interactions. So to be able to run it, we need a very high level spatial data on pressures, the human activities that cause the pressures, and of course the ecosystem component raster layers, and also this sensitivity score table to match between them. The resolution that have been used is 1 by 1 kilometer grid. So when we do that in the whole Baltic, it results in some more than 400,000 cells where this is analyzed. And the tool outputs and the tool code is available online, so it can be taken into use by anyone, either using the desktop tool or the online tool to test and do some testing with different pressure ecosystem component combinations, for example. And it has been used, as mentioned in the State of the Baltic Sea report, to assess areas which are most impacted by human activities. And the same tool was also used in Pan-Baltic Scope project to compare different offshore wind energy production development scenarios. So there was some modification to the input data done based on these scenarios, and that was overlaid on the map that can be seen. On the left-hand side map there is the baseline, and on the right-hand side there is the scenario on having high amount of wind farms in the southern Baltics. Of course, there is these synergies effects as well, which can be analyzed with these kind of tools. So they can do quite a lot of analysis and scenarios when applied to that kind of use. Then one other tool developed in the Estonia is the Plan-Wise for Blue tool that quantifies cumulative human impacts on key ecosystem elements. And it is also done on 1 kilometer spatial scale. And this tool also combines layers of key nature asset values based on the current best available data and knowledge. And similarly, it contains rules on how different human pressures affect different nature assets. So there is this kind of same kind of thinking on having some sort of sensitivity score table or other kind of a rule network on how these pressures interact with nature asset values. And this tool also contains functionality for user to upload polygons of human use. So it has this kind of a interactive element, and that is something that is useful for planning purposes and this kind of impact assessment. And this tool has been tested in the Estonian maritime spatial planning process. Here you see example of the wintering bird areas map on this tool. Then we have Mytilus tool, which is developed in Denmark, and it is a general purpose tool for cumulative impact assessment. And the spatial scope spans from local sea areas over to regional seas like the Baltic and to the global level. So there is flexibility on with geographical scale it can be applied. And similarly, the map results are in the same spatial resolution as the provided input data, and it can be aggregated to larger units. And it's scenario-based, and it supports assessment of alternative plans as well. It supports a broad range of calculation principles and also includes tools to assess conflicts and synergies between maritime uses. And I think today we will hear a presentation from Henning on this in more detail, how that can be done and what kind of outputs can be taken from there. And this is a desktop application running on Windows, which is also free and open source. So there is this kind of a possibility for anyone to take this into use. Then we have the Symphony tool from Sweden, which is developed for the Swedish MSP in 2015 and continuously developed. It contains, or it takes in 40 pressure layers and 32 ecosystem component layers as raster files. So that is common for all these 4 tools, which are then downsampled to Symphony Grid, which is used for this. And spatial resolution for this tool is even 250 meters, so it is a bit more detailed than has been used for the other tools. Or they are also kind of independent from the. You can run it on many resolutions, but usually the limiting factor is actually the input data, which sets the resolution. And Symphony is owned by SWAM and is open source, but not published yet. And it has been used in the Swedish MSP for evaluation of planning alternatives, communication of the plans, and the CEA document. And it has been also taken into use beyond the Baltic in this international context on Nairobi Convention, South Africa, and will be in the UN Ocean Conference. So to conclude something on the existing tools, I think we can say that these tools are rather similar. In fact, they are all based on Harpen type of method. They ingest spatial data, raster files typically, in quite detailed resolution depending on the tool. And what is common, of course, for all these tools is that they need spatial data as good resolution as possible. And I think it can be said that any tool can be only as good as the data that goes into it. So they are not like magical black boxes that come up with some surprising result, but it simply is the result of all the input that goes into it, and in terms of pressure layers, ecosystem components, and the sensitivity scores, or these factors that interact. And for the Baltic scale, and I think also in national scale as well, there is need to get data products that cover large areas rather than point-wise raw data. This is because all these tools have very high resolution, and there is huge amount of raster cells that have to be filled in some way. So that is where modeling comes into the picture. But also there is, of course, need to have these extended surveys to really validate the model data sets. And I mentioned this Pan-Baltic scope example as good one for tackling the issue on data availability on essential fish habitats, which was then became available thanks to that exercise and work done under that project. So that is something that would be direly needed for other ecosystem components as well. And also one thing that has been concluded is that all these tools have a certain good kind of innovations or ideas that have been taken into use, and it would be beneficial to harmonize the approaches by picking up the best elements of each tools. And within HELCOM, for the upcoming State of the Baltic Sea report, there is work underway to develop this advanced way of the spatial pressure and impact assessment tool, which will try to tackle some of these points, like having being able to do this kind of a localized assessments and having more emphasis on how the sensitivity scores are defined, and and of course looking into the data availability issue, which is like a never-ending challenge, but there seems to be some improvements in the pipeline, and also looking into this ecosystem, like aggregated areas of high nature values is something that can be obtained from these tools. So that is to conclude this presentation, and I thank you for your attention. And this is just touching the surface of the CIA tools, but I think we will be discussing this more today in the panel discussion and in the upcoming presentation. So thank you from my side.
Thank you, Joni, a lot for this review. It was quite interesting. For now, there is no question, but you can actually include it in the chat, and that we can actually answer them during the panel session. Thank you, Joni, for this. And now I can introduce our second presenter. It is Dr. Henning Sten Hansen. Henning is holding the full professor position. Dr. Henning Sten Hansen is holding full professor position in Aalborg University. He's a head of section of geoinformatics and land management. He holds a doctoral degree in coastal zone planning in a climate change perspective. His main research interests are geospatial analysis and modeling, MSP, coastal zone planning, and climate change adaptation and mitigation. He has developed Mytilus software for assessing cumulative impacts on marine ecosystem from anthropogenic pressures. Henning Sten Hansen had participated in several projects on MSP and was a coordinator of Bonus Basmati that was actually finalized in 2020. So Henning, the floor is yours. You have 10 minutes.
Yeah, thank you very much. My voice is not perfect, but yeah. I will tell about analyzing conflicts and synergies between anthropogenic uses in the marine environment. This work has been carried out by my PhD student, Ida Maria Bonnevie. Actually, she will defend her thesis next week. And myself and Lisa Schröder as main supervisors. Oh, it's working remotely. I have to go around the world twice or so, so it's a little delay. Maritime activities, yeah, if we go back not so many years, it was mainly focused on fishing and transport. But now we have a lot of other things: oil, gas production, aquaculture, cruise shipping is growing. Perhaps now it's declining quite a much after COVID-19, but it will probably come up again. Wind farms, and yeah, there's so much activities in the marine space, and there's of course also leading to competition between the different users. I think that many of you have seen in the news some headlines talking about synergy conflict relationships between maritime users, offshore wind farms impacting seabirds. It's only a month ago, I think, that they planned a new wind park in Denmark, and now it seems that it will be not allowed due to it will harm some seabirds, and so it's really up to date. We have also experienced that these can also be transnational. We have seen conflicts with Sweden because the Swedes again wants to protect the birds while we wanted the wind turbines. But it's not only a bad thing for wind turbines regarding the sea use, because it can also have create synergies by establishing artificial reefs, especially the foundation of the basement of the wind turbines. You can also have multi-use with tourism and agriculture, where you can go around and look into these fish or mussels or what it is. And of course, at the end, you can say that okay, we have now some very good synergies created by several, or at least two maritime activities, but perhaps they together will have too high environmental impacts, and this is what Joni just talked about a few minutes ago. This about use interaction is quite complicated. It can be in many different ways. You can have location links, and you can have environmental links. Location links, it's actually that there is a connection between extent and duration of use. You can have environmental links where environmental impacts, aspects of one use can affect other uses. You can destroy the ecosystems, for example. And technical links can actually create synergies, for example, by reusing some infrastructure components developed for one use, but then reused or in collaboration with other activities. So there are several kinds of use interactions overall. If we then go into synergies and conflicts, it's not so, they can also be done in different ways. For example, interaction, mutualism, where we have interaction between two or more users, where each use has a net benefit. That's a really good situation. That's what we want to gain. Commensalism, where interaction between users, where one use gain benefits while the other neither benefit or are harmed. So we have these two synergy types, and then the conflict types. Amensalism, interaction between two users where one is destroyed while the other remains unaffected. Or antagonism, which is, of course, we should try to avoid, is interaction between two users where the two users adversely affect the other ones. And then, of course, we when we are dealing with these conflicts, we can apply different weighting methods. Here we have just in the first element, we have used both binary weighting, but also ranking of the scores. I'll come back to this in a moment. Now my other computer go into sleep mode, but now it's here. It's we have developed this formula where we calculate the score, and in a way it's quite similar to the HELCOM formula developed for the cumulative impact assessment on marine ecosystems, where we have two activities, and then they are just multiplied. And multiplied with a sensitivity matrix, and then summarized in total. So we have, this is tested in the Baltic Sea using HELCOM data from the portal, and we can have this matrix of activities in rows and columns. And then we have deduced the conflict synergy scores from existing international MSP research project, from Baltic Scope, Aquaspace, Plant Bosnia, Participate, Muses. The last Muses was a quite big one, only focusing on multi-use. And and this gave us some insight into what could be the reasonable weighting. But as it is in the cumulative impact, which Joni told about, this about the impact matrix is very sensitive because it's based on expert opinions, and there will be some guesses. We cannot know everything for details, so therefore, of course, this is one of the weak links here. We have then developed a Monte Carlo principle to assess the sensitivity for these weighting scores, or the so this and this of course gives us some idea of what could be the room, the limitations of the results. We have developed this as pairwise use examples. For example, the wind farms and commercial fishing, they are for sure non-compatible. But the potential neighborhood synergies through artificial reef effects means actually that this will have a positive score. But again, this is what our studies has shown and our own reflections, but it's not so exactly stated that this is positive. It can also be, and in positive 1.25, it can also be something else. So this is the weak part of this methodology, as it is for the cumulative impact. Some years ago, we developed this Mytilus for cumulative impact, and then this is extended also to contain conflict and synergy analysis. Because in the way we consider conflicts between maritime activities or uses in a parallel to cumulative impact analysis on the environment, because they are both conflicts emerged from maritime activities. So it's just that they can harm other activities or creating synergies, or it can harm the ecosystems. But then comparing such a conflict map with a cumulative impact gives much more insight, and you can see here that I have just chosen all activities, but you can select activities, etc. So you have many options to do this. And again, for the synergy analysis, that you can do the same, and in that way, I identify area where there are potential for co-location. This is also we have also developed some efforts into identifying area for co-location. But of course, this is not here. We can not only look into the potential of synergy, because that could be it could provide good meaning to have a co-location between two maritime activities, but at the same time, one of them may harm the environment. So then it's no-go, or at least it has to be balanced against each other. And the last one, I hope I'm within time. MSP aims at allocating marine space for blue economy without severe impacts on the marine ecosystems. This is the main also focus for the directive from 2014. And this is addressed in the cumulative impact assessment, but at the same time, maritime activities also compete for the limited marine space, giving room for conflicts, but of course, as I have said, also synergies. And such a tool for conflict and synergy analysis provides additional knowledge before decision making on the use of marine space in MSP. I can say that this work on conflicts and synergies was part of this Bonus Basmati project, which I coordinated the previous, ended in 2020. So, thank you for your attention.
Thank you a lot, Henning, for this quite comprehensive presentation about the co-use and multi-use, and how did you actually define the synergies and the conflicts, and how did you waiting. I think it was quite interesting to see how it's included in the meat of the software. Thank you a lot. We can come back within the questions after, and we can now invite our third presenter. His name is Ikauniece. She is a senior researcher and head of marine monitoring department in the Latvian Institute of Aquatic Ecology. Sorry. Okay. She holds a doctoral degree in marine hydrobiology from University of Latvia. Her research interests include functioning of planktonic ecosystem and mutual relation with ecosystem, and possible way towards more advanced methods of environmental measurements. In addition, Anda has worked with development of marine research program, assessment of societal attitude towards the wind parks, sustainability aspect of MSP, and potential perspectives of blue growth in the Baltic Sea region, of course. So Anda will tell us about problems and gaps related to cumulative impacts identified by the BlueBioSites Seed money project. And the floor is yours, please.
Thank you, Andre, and hello to everybody listening us today. So BlueBioSites project was already introduced yesterday in the pitch session, and so it is about finding the best locations for blue bioeconomy activities in the Baltic Sea. And I should say that the seed money project I'm representing today, they are meant for preparing the main project, or more precisely, the main project proposal for further submission, and in the case of luck, also for further funding. Therefore, the first task for seed money projects is to have an updated view what happens in the respective field the project is about, and also to identify the gaps and challenges the main project will have to address. So therefore, also the content of my short story is based on state-of-art report of for BlueBioSites project. And we are 8 partners in the seed money project, and representing Baltic Sea EU member states. And besides Submarine Network, Angela was representing the BlueBioSites yesterday in the pitch session. The rest of partners are of academic nature, experienced in maritime spatial planning, related issues, and also working with resources and sites for blue bioeconomy. And the question you see on the screen, how, asked how to, and the aim to support MSP. These are setting the scene for the main project, as I introduced before, but definitely frame the scope of themes the seed money project should tackle. And for the BlueBioSites project, we are thus addressing blue bioeconomy, which is a smaller share of blue economy. And we have included our project's scope those activities or those sectors which are present at first in the Baltic Sea region, and also those who are directly related to marine space. to the need of use of marine space. So we are addressing cultivation of mussels and algae, collection of beach wrack or beach cast, marine fish aquaculture, and floating islands. And activities or sectors like biotechnology and tourism in this case are not included. For sure, if at first we need to understand what is the range of blue bioeconomy sectors at each country, although we have one common sea and are making common assessments for our common sea, the plans, both MSP plans and economy plans are made nationally, and conditions certainly differ at each country. Maybe as we all know, or maybe we don't, but we have several natural gradients in the Baltic Sea, in salinity, in temperature, and coastal geomorphology. And the presence of blue bioeconomy sectors reveals these natural gradients to some extent. You can see that countries with more marine conditions at their coasts, it means higher salinity, and also maybe more appropriate coasts like Denmark and Sweden and Germany, they possess also a larger number of sectoral activities. And certainly also traditions and geomorphological features play a role. Like, for example, collection of beached algae, as you see as beach wrack here, as a part of industrial process is present in Estonia for decades. While at the same time in neighboring Latvia, with so many kilometers of sandy coasts, this collection of beach algae occurs only at very small scale and episodically. Then fish aquaculture in this list is the sector with the longest history, and therefore also has gone through most mistakes and changes, and also received the most negative attitude due to its impact on the marine environment. And we should always keep in mind that blue bioeconomy in the Baltic Sea is not possible with a negative impact on the marine environment. Professor Hansen already showed it in his presentation that maritime spatial plans try to plan the space avoiding these negative impacts. And the same is certainly true for blue bioeconomy as a part of blue economy. And therefore, the sectoral activity, which is called floating islands and maybe sound strange, it is the youngest child in the family, and its aim is certainly to reduce the negative impact of other human activities on the environment. It's a small artificial construction, and it's not moored, it's floating. And floating in especially at the places which are shallow and which have high content of nutrients and expression of eutrophication in the basin. So the development of these sectors differs between countries, and sectors themselves, like mussel cultivation and fish aquaculture, as well as algae cultivation, and also beach wrack collection to some extent, are already commercially running, while floating islands, which I mentioned, it is still on a more experimental and trial level. So if the processes or sectoral activities are commercially valuable, then it's no surprise that they are receiving also more attention. And then hopefully not only due to possible profits, but also by creating the impacts. And therefore, finding the sites for blue bioeconomy they are like more developed for those commercially valuable or commercially running sectors. Site selection are clear, and decision support tools are mostly in place for fish aquaculture, and to a larger part also for mussel aquaculture in Denmark. And for example, in Finland also the granting of permits for fish aquaculture are linked with Maritime Spatial Plan. And Estonian and Danish recently adopted the Maritime Spatial Plans also foresee certain bioeconomy sectoral activities in their plans. And Joni already mentioned the support tools or decision support tools which are present in the Baltic Sea region. And I will just add that there are already developed decision support tools for mussel and algae cultivation by Baltic Blue Growth Project and developed by University of Tartu. And Jonne Kotta will probably cover it more during our discussion. And there's also a tool for mussel cultivation impacts called Mitigate. And so these are like more or less clear, we should say, although there are, minuses still. But activities or sectors like beach cast and floating islands, they are based on our experience with these sectors and data available. So mostly relying on expert judgment and less on calculated impacts. So altogether with blue bioeconomy and cumulative impacts in the Baltic Sea region, we should say that the size of blue bioeconomy, as Angela already stressed yesterday, it's still tiny. And in most cases in the Baltic Sea, yes, locally it can be important and also probably creating some impacts. But if you look at the Baltic Sea scale, then it still is minute. And it maybe sounds boring, but we still miss knowledge on activities, and not on only activities, but those pressures they are causing and the responses we are receiving due to maybe not so developed this blue bioeconomy. With blue economy, it's easier, I should say, because it's mostly physics and you can calculate and model it more easily. But when bio is involved, then it's always creating some difficulties. Climate change impact should be considered when talking about cumulative impacts of blue bioeconomy, and also boring, but we still do not have enough data because blue bioeconomy sites are still assessed locally and should be assessed locally. And certainly the certain types of data are still missing and should be collected, those social aspect and attitude of inhabitants towards development of blue bioeconomy sites. And then we should remember that parts of blue bioeconomy are working, let's say, as a measure against land-based impact. So it's really a kind of complicated case when we should assess the impact of blue bioeconomy activities themselves, and then also as a measure or as a helpful tool against land-based activities and link it both together. So I should say that the main project of BlueBioSites certainly will have an area to work for. Yeah, thank you. I missed my thank you title on the last slide, but that was what I wanted to say about BlueBioSites project and further developments. Thank you.
Thank you a lot, Anda. And I think you emphasized a very important aspect that although this sector is still very tiny. We've done so far, but at the same time, we still miss a lot of data, and hopefully the decision support tools may help us with further work. So we really hope that the big project will get approved, and we will continue to explore this field. But now, as we will switch between the presentations and the panel discussion, we will have a short interactive break where we would like to find out a bit more about the participants of this workshop and your background, which might help us to build a more constructive discussion at the next part. So now the first question in the poll section is open, and if you click on this info button next to the comments, then you will find it. And the first question goes or asks you from which sector are you and which sector do you represent? And there are many answers possible, like community, culture and heritage, energy, extraction maybe, or environment, etc. So have a look, and please click your answer so we know who is here in the with us today. Okay. Now I see that many, half of the participants who have participated in the poll represent research. Some are representing other field. Maybe we will figure out it during the rest of the workshop who that field is. When I update the results, I see that also we have also those involved in working with the environmental issues and energy, as well as someone from the governmental authorities. So I would say quite a diverse picture, and as typical in MSP, there are various stakeholders from various fields, and you have to juggle among all of them. Very well. Yes, it seems to me that the results are not changing that much anymore. So we can maybe move on to the second question. And the second question is about the decision support tools. And how do you see those? Whether they are useful or not useful, or maybe they are very useful. What's your opinion about the decision support tools and their usability? The initial results are very optimistic. I see that all of you think that they are useful or very useful, which is a very good start for our discussions. And it shows that the work done in this field is very relevant, and we have to keep it up. And the final question, the final poll we will have before we move to the panel discussion is about your experience with those decision tools. And have you ever used or applied any of those decision support tools? Can we have the third question, please, on the poll? So the third question is open. Please share with us whether you have used any of the decision support tools in your work so far. Nice. So we see from the results that the majority of you have used or applied one of the tools, or maybe even multiple of the tools before. So you have some experience, and you can definitely share it in the chat with us. And I think then it makes the upcoming discussion even more exciting. So at this point, I give the floor back to Andrei to conclude with the panel discussion.
Thank you. This was quite informative and interesting to see who is on the other side and to have feedback from them of use of the tools. So we can start within the next point of the agenda. It's the panel discussion, and I would like to invite all the presenters to join the panel. But also I would like to introduce Ms. Dr. Joni Kaitaranta, who was the leading researcher in PlanWise for Blue project. Joni Kaitaranta holds professor position at University of Tartu. He's an experimental ecologist, specializing on patterns, dynamics, and processes of the coastal ecosystem under current environmental conditions and future climate change. His research includes, among other topics, trophic networks, benthic pelagic coupling, and scale-dependent relation between environmental forcing and biotic patterns. He has extensive experience in invasive and outbreak species as model organism in order to establish relationships between species addition, deletion, ecosystem functioning, and dynamics. So please welcome Joni as well in the panel session. So for all the participants of the workshop, I would say there is a question in the chat which should be included, and we wanted to know if you use the tools, and we saw from the pool that actually use the tools, the decision support tools, we would like to know how did you apply it? How did you use the tool? And for others who did not, maybe you can actually provide how can these tools could be more useful. If you respond to this, just click on the respond button if it's, I don't know if it's already there, but okay, it will probably appear soon. But to start the poll, maybe we can start within the first question, and it will come to me before the chat starts to go on. I would ask all of you one thing. The developed tools are open source. They are usually available for download. If they're web-based, you can actually already introduce the data, but you can introduce your data. But with all this work, what is developed, is it difficult to find the users of developed tools? Now, how difficult it's for users to use the systems? Now, we developed manuals. I see also the manuals which are the video manuals that actually quite nice explain how to use the tool. But can we actually compete within the commercial software that has this very intuitive, very well designed the graphical user interfaces? So maybe Joni can start.
All right. So hello from my side. Well, this is a interesting question. obviously. What I can only tell from my side, my experience. And then, so we didn't generate a tool for sort of earning money kind of thing, but it was more like we had lots of meetings with other ministries, especially those with planning departments, but not necessarily only those. And then they very much needed certain analytic capabilities, which they didn't possess in their house. So the tool was sort of generated to fulfill their aims or targets. So in that respect, it was like a tailored tool for end users. And this is such a niche product. I don't think there will be ever any commercial company that would like to compete with it, because this is super expensive, time consuming. You have to have lots of enthusiasm, etc., etc. So it's more like a interaction among different stakeholders, like enterprise, ministries, universities, like working together for the same goals. So this is sort of my view on this, how it moves on. And this is very dynamic. So probably in a year, 2 years time, we have completely new things as the technology is developing, needs are modified. So it's we consider this as a process, not like a kind of static thing.
Thank you a lot for your answer. You're very, very right. Maybe from the Mytilus, Henning, would you like to also?
Yeah, Mytilus is developed in a totally different context. It's developed in European Union projects, starting in a North Sea Interreg project 5 years ago, I think, and this was because we needed this kind of tool for this project. And then it was further developed in the Bonus Mathematics project, but it is more or less a research tool. It's our ambitions to do this for actually research. But on the other hand, it's extremely user-friendly, so it can be used by more or less everybody. So it's not so, but I think that we can observe that when this is used in a well-defined MSP context, like Joni Kaitaranta told about the Estonian case, and we have seen Symphony. It's owned by the Swarm, which is responsible for MSP projects in Sweden, and so in that way. They are targeted exactly to their needs, but then perhaps not so user-friendly, because it's only expert users. I think that I don't know if I'll be able to run a plan for Wise Blue, but it's they are typically the problem with tools like this is that you will always expand. We have expanded with conflict and synergy analysis, and we also heard that Joni, he said that in 2 years it will be a total new tool models, because you will have a new series, you will have a new technologies, you will have more data, etc., all facilitating the development of a new version. And then, of course, the new version will also have some beta character. It isn't. It's never finalized. So this is probably one of the main challenges, and of course I'm also following this work in HELCOM on cumulative impact, and we can also see that that it's very difficult for HELCOM just to collect data for the whole Baltic Sea region in the same resolution, in the same collected during the same time period. Some data are from 2012 and others from 2017 or where else. So of course this all put together a lot of uncertainty, and what is hated by HELCOM is more flexible. There's not a minister saying we have to do this but for a practical MSP process under a minister, then they hate the word uncertainty. Uncertainty. Why should we pay you for doing consultancies, and then you cannot tell us exactly the right number? And I would actually, if I'm allowed to ask Joni, how are you handling this in the Ministry of Finance? I think it's in Estonia. I think the Minister of Finance, they always want to have exact numbers.
Yeah, this is actually, I can reply you. I was astonished that our ministries, they started to ask about uncertainties a couple of 3 years ago. So we are very well educated in a way.
Okay.
They understand that we have the expected effects, but also uncertainty. So I'm truly happy they accepted the world we are living in. And this is super nice because due to uncertainty, you can actually pick up the research way forward. So if low uncertainty, you have to investigate. Is it because of data, or is it because of knowledge, or is it something else? So it's I'm super happy with the situation currently. So actually happy that you put this forward, but we need to educate ministry people, I believe.
Good. Thank you. Yeah, it is very good actually that you're already developing the tool for not only for the research, but also where you have already the end users with yourself. So this is a very, very good thing. But also there is always possibility that the tools can be used as mainly what I see, the tools which are developed are on the Baltic level. So they can be also be used by the other ministries, by the other countries. And this is actually a very interesting thing. Now, actually, it looks that chat started to work quite well. There is a lot of questions, and I would like to start with the first one, which is included there. It's coming from Kemal Pinbasi, who actually make a quite interesting paper on the decision support tools in MSP. And he asked, what are the main challenges of data collection in the Baltic Sea region? What do you think about the harmonization? Who would like, Joni?
Not an easy question to answer, but I think the main challenge actually is the data harmonization. And as Henning said, there is challenges in getting the same kind of data collected from all the Baltic countries. And within HELCOM, there has been work to provide guidelines, data formats, and data collection methodologies that countries would follow in their HELCOM monitoring. So that is rather well developed for the biological community data, like zooplankton, zoobenthos, this kind of traditional environmental data, like nutrients and so forth. So that is quite well handled. Of course, there is challenges there, but it's quite well developed. Then we have these data sets that are not regularly collected, and there is not like a regional specified format necessarily, and not regular annual reporting of that data. So that is where the challenges come, and there might be differences in national legislations for collecting, like nationally, this data. Like one of my favorite examples is the dredging data, that there is for certain countries you have to report very small scale dredging to the national authorities, whereas in some other Baltic countries there is only like the large scale dredgings are collected nationally. So when you put this when you receive this data from the countries and you put this together, you have to be very careful on how you kind of filter the data, what kind of conclusions you can draw from that. So that is something that we have tried to work further for the upcoming State of the Baltic Sea report, that we harmonize this data that is not regularly collected. Then there is the existence of these like highly mobile species, where we really need this kind of international EU level, Baltic level data products, like for bird migration routes. That would be really beneficial. For mammals, where they are located in like some sort of modeled result. Harbor porpoise is something that there is already some data available, but better and more precise data for the whole Baltic would be needed. So there is challenges, but I think as said in the presentation, it's more related to the biological data rather than the human activities and pressures, which of course are not perfect as well, but I think more on the ecosystem side.
Okay, thank you. Yeah, species distribution data, it's always very difficult to have it, and actually you can always have the observations, but to get how the species are distributed, this is much more difficult to understand and actually include within the MSP decision. Anyone else would like to add, respond on this question?
If I may.
Of course.
So
please.
It's adding up to Joni's talk. I think what we miss in many parts of the Baltic Sea is like lots of areas are not mapped. And this is a huge uncertainty. But when we're running these cumulative impact assessments or other types of assessments, we need data for all grid points. And that brings us to modeling, because we need the modeling layers. And this is something what's already happening, but we need it much more. So we need a harmonization of the modeling products among countries. So we have some project, or sometimes also like a bilateral collaboration with different countries like Estonia, Finland, Sweden, etc. But we need to sort of having a broader umbrella thing that guides or kind of coordinates this modeling thing. Because if we have reasonably good quality data, harmonized like a HELCOM standard of the biological data collection, and we have a reasonably good modeling or harmonized modeling products. So we might even reach within a pan-Baltic scale good modeling products. So this is very much needed, and this is a big challenge.
Yes, very interesting thing to have this approach of the harmonizing the modeling results. This is interesting. And yes, of course, the area were not mapped. You're probably referring to the habitats and what actually.
Yeah, habitats, but also birds, seals. You have lots of data which we lack information, and we need to fill in modeling or actually start some traditional mapping programs. So and this need to be analyzed and carried out.
Okay. Thank you. Okay, we can go for another question from audience, and it's very well go on from the topic what we speak before. Well, it actually says that can we already use the tools in the Blue elementary schools for the ocean literacy, for the Baltic Sea Twin, DG Quorum, Ocean Twin? Anyone would like to? Henning, please.
Of course, it depends on how elementary schools we are talking about. But I think at what we call gymnasium level in Denmark, I don't know what's it's a bad word to use, but just before university level, that for example, Mytilus would. It would be possible to use this because, as I said, this is very user-friendly. But of course, the challenge is that they understand the principles behind. It's not so that the Halpin's formula is very complicated, but so I think that it could actually be used in a higher level school on the university level for this one. But of course, they need to have the sufficient biological knowledge. Otherwise, it will be just fun.
Okay, thank you. The other question from the chat. Good. Maybe we can also come back on the questions of the data gaps, which is always quite lots of topics about. And I would like to ask what is the more relevant information gap? No, if you don't have a data, what actually you want to mention that you can actually model, or maybe the data gap of the time series of the updating, it's something which is more serious and more relevant for the cumulative impact assessment and also for the maritime special planning. Yeah, please.
Yes, it's clear what Joni said, that that the areas where there are no where we can actually say empty cells, it's of course a very, very serious problem, because first of all, it would be nice if HELCOM could provide a data layer for each data where we have actually no information provided for this cell. Perhaps that could confuse somebody, but from the research community, at least it could be nice to know, because if you have no knowledge, this is not the same as zero. The value of zero is very, very different from no data. And this is what I have been quite much concerned about. Also, for example, the interpolated values for in some of the data layers, it would be nice to have the original data, so you can see the point density. Where do you have the highest uncertainty in the data? Because if you are using 1 kilometer cells and there are 20 or 50 kilometers between the underlying data point, this is a big challenge, while in other areas it can be extremely high density. So and if you want to have good quality assessments, then you need to be able not only to understand the uncertainty of the sensitivity scores, but also the data layers behind. That's I think this is a main concern.
Yeah,
if you will comment, Joni, or.
Yeah, no, I'm fully agree with you. And then I just, as it was asked about the time series, so I would like to reply that we already have so much challenges with the spatial thing. So first we have to kind of solve the issues, what we have about space, and then go into time. But what we can do and what we've been doing, it's actually all these cumulative impact analysis are more like a scenario analysis. So we can always pick up sort of scenario, either it's like a future management or future climate change or mixed of those. And then we can model like some biota layers representing these future scenarios. And we can sort of run analysis in time, because we can play with different scenarios. But it's a mission impossible almost, like to get all these biological layers covered in space and time. So it's certainly the modeling thing, but before modeling, we have to have a knowledge. And that's a huge thing. And it's not like we are missing a knowledge. We have a lot of knowledge nowadays comparing, or if you look like a scientific literature, but it's so scattered. And we need a huge efforts to put everything into a sort of same package. And this comes to either like a sensitivity scores that are currently in many tools sort of static thing, but we need to build a international pool of knowledge of sensitivity scores, and not just like a based on expert judgment, but more like we are looking all single publication evidence that are publishing effects of separate or synergistic effects of different human pressures and different nature values. And then we use this sort of in a network analysis or some simple form of analysis. And then it's going to be dynamic, and it's reflecting the current knowledge in science. So this is a big thing. We tried to do it like in nationally. It took us 3-4 years, I guess, but it might be really challenging or good thing like to join the efforts. To have like, I don't know, in HELCOM or some other like a regional organization, have this pool of knowledge and everybody's like contributing, and we can receive like a web map service. So it should be sort of, machine reading thing. And then everybody can benefit. And this is also a start of harmonization. So you can consider it future work in HELCOM, for example. Yeah.
Thank you. This was a quite good answer. And I think what you mentioned, it's a way to go. No? I would just like to very fast question to all the panelists. Joni mentioned the chimera of Frankenstein, which you are going to do within all the projects and the tools that you actually developed. It's called Spatial Pressure and Impact Assessment Tool, SPIA. So the idea was the picking up the best elements of each tool. And I would like to ask you, what actually do you expect very fast, because we're finalizing the workshop. What do you expect from this work and this workshop?
Yes, thanks. I think this touches upon the suggestion that Joni made just recently, that we aim to build this pool of expertise from the whole Baltic to, but first of all, refine the sensitivity scores, that they are, first of all, refreshed and updated based on the best current knowledge. Then we also need to further develop this uncertainty topic as well, because it was also the wish from the HELCOM higher level groups that we need to communicate uncertainty in a better way than it was done in the previous assessment. So I think our decision makers are quite well educated to this uncertainty, so it's kind of required nowadays also. So that those things are what we look into. Then we also, of course, look into these data gaps and possibilities of using these modeled results so that we can fill in all the pixels and not to have these empty ones. But it is possible for some data. But that is very briefly what we hope to achieve in the next 1 or 2 years. Thanks.
Thank you. Anyone else would like to comment this, or we can close the panel session? Okay. Thanks a lot for questions from the chat. Thanks a lot from the panelists. This was short. We could go on much more, but actually we have an agenda that we can fulfill. And I would like to close this session and pass it to Liane, who will actually close the workshop.
Thank you, Andrei. Thank you to the speakers. I was excited to follow your discussions and also to see the interaction from the audience. And indeed, we have come to the conclusion of this workshop. And to sum it up, we would like to invite all participants to contribute to the word cloud, which is already open on the platform. And please note down in one word what was your main learning from this workshop. We start to see a few words coming into the word cloud. In case you have missed it, you can try to refresh the page and you will definitely see it. We see such things as uncertainty, which was really an exciting part of the discussion and how to address it. We still see collaboration as in any other field, as well as balance and difficulties with harmonization. And yeah, but seems like that harmonization is one of the key things that the audience has taken with them in this workshop. Okay, at this point, we have reached the end of the workshop. It's 12 o'clock and in Riga, and 11 in Berlin, and 10 in Canary Islands. So I would like to say a big thank you for all the speakers, for the great moderator, Andre, who was with us in the Baltics today. And yeah, so enjoy the rest of the conference today, and hopefully see you in some other occasion.